Hello, third graders. Mr. Bowlby here. I'm so excited to be able to join you on this distance learning adventure. And we are going to be teaching our lessons through the webcam here, pre-recorded sessions, so that we can have time to discuss and have assignments posted onto the Canvas platform after that. So I'm looking forward to the lessons as we go. So let's go ahead and get started. We are in the space unit, our solar system and beyond. And the first lesson is our planet Earth. So go ahead and shrink my little face there. All right, here's some vocabulary words you can focus on. Feel free to pause and write those down. Just remember them, look at the definitions, try to remember what those are as we read the story or the domain lesson. They will come up. All right, so the purpose of listening. Now, students, you are learning about our planet Earth. You're learning about outer space. I want you to be able to predict what you might include in an address if you're addressing an envelope to your school using a space address. Now, astronomy is the study of things that are very far away. Now, even though the tools and methods of science allow astronomers to know that there are things in space, we are not always able to take photographs of them. A number of the images in this domain are photographs of actual space things, but some of them aren't. Some of them are just digital simulations, diagrams created from real photographs, digital recreations that are partially rendered based on measurements of what we see in space. Because again, some of the stuff we can't draw, some of this we can't take pictures of. But we are going to show you some good stuff. Now, if you travel to another country and someone asked, where in the world is your school located? You might answer by giving the school's address. Its address explains where your school is located on the planet Earth. Now you have your school's name, the number and the street name of the street, your town and city, state and zip code, and your country. The mail carrier could find your school and deliver the envelope from anywhere in the world. See, you have a picture here of an example of anywhere in the world. This is a little bit more familiar. You can see Patrick Henry Elementary School. I'll give you a second to ooh and ah about that. Edison is over here. Harvard, up and down, north and south, Yale. Got the mall, you got the Ghost Town Mall over here. You got the movie theater. All of this stuff, which we can't visit right now. That's okay. Our school's name is Patrick Henry. Our street address is 3820 East 41st Street. We live in Tulsa. Zip code is Oklahoma 74135. And this country is the USA. But let's pretend you traveled far, far away to a distant place in outer space. And an extraterrestrial being asks you, where in the universe is your school located? How would you answer that question? You would need to give someone who lives far away from Earth more information as part of your school's address. A space address. That explains where your school is located on the map of the universe. Now, the first part of your space address that you would want to be able to add to the envelope is your planet, Earth. Now, you might think you already know everything there is to know about Earth. After all, you've lived here your entire life. But what do you really mean when we say we live on a planet? The word planet means wanderer, a name ancient Romans gave to objects in the sky that appeared to wander on a different path than the stars did. As astronomers have continued to observe and study space with more powerful tools and learn more, they keep thinking about and discussing the exact definition of a planet. Scientists today classify a planet as having 5 important qualities. 1, a planet is a sphere, or a nearly round object in space that has a large mass. Now, a sphere, like that, a very large mass. Planet is a sphere, or a nearly round object in space that has a large mass. Planet travels or wanders in a path called an orbit around a star. A planet has cleared out most other objects from its path as it orbits the sun. A planet is mostly made of rock or gas or a combination of both. A planet does not make its own light, but shines in the sky because it reflects the light of the star it orbits. Now the planet, I'm getting too close to the sun. Goodness. Okay. Nice and warm here. Roast marshmallows. Planet Earth is made of rock and orbits a star you already know by name. Can you guess it? Earth's star is the sun. The sun, like all stars, is an enormous mass of incredibly hot gas. Anyone that's watched The Lion King knows that. But it creates a huge amount of energy in the form of light and heat. Earth is one of 8 planets that orbit the sun. Actually, Earth is the 3rd planet away from the sun. 93 million miles away, to be exact. That's a long way. If you drove from Earth to the sun in a car going 60 miles an hour, you might travel on a highway. It would take you almost 177 years to get there. And that's without stopping to stretch. Most living things on Earth need heat and light from the sun to survive. 93 million miles may seem far from the sun, but it actually is the perfect distance for human, animal, and plant life on Earth to exist. You can think of the sun's energy as being like the temperature of Goldilocks porridge. If the sun were closer to the Earth, it would be too hot. So hot the Earth's water would boil away. If the sun was further away, it would be too cold. So cold that all of Earth's water would freeze completely. As it is, Earth's position in our planetary system is just right for life. In fact, Earth is the only place in our sun's system of planets, or in the entire universe, where we know life exists. Now, another reason life can exist on Earth is because of Earth's atmosphere. An atmosphere is a covering or envelope of gases that surrounds a planet. Earth's atmosphere traps the sun's heat, keeping it near the surface of Earth. This keeps Earth from getting too cold. Earth's atmosphere is all around us. Take a deep breath and hold it. You have just breathed in some atmosphere. Now breathe out. Your breath has just added something to the atmosphere. Besides providing the air we breathe, the atmosphere also protects Earth. Have you ever slathered on sunscreen to keep from getting sunburned when you go outside? Earth's atmosphere is like sunscreen for Earth, blocking some of the sun's harmful light rays from reaching Earth's surface. Earth's atmosphere also diffuses some of the sun's light. This is what makes the sky look blue. In images of Earth as seen from space, it's easy to see the blue of Earth's ocean. Water covers about 70% of the planet Earth. That's a lot more than half of the surface of the Earth. Earth's water is essential to support plant and animal life as we know it. One moon orbits Earth many miles. One moon orbits Earth many miles beyond Earth's atmosphere. Earth's moon is by far our closest neighbor in space, but it is still far away. Do you remember the classic Mother Goose rhyme? Hey diddle diddle, the cat and the fiddle, the cow jumped over the moon. The little dog laughed to see such a sport, and the dish ran away with the spoon. Well, that was one high-jumping cow. The moon is about 239,000 miles away from the Earth. So if the cow jumped from the Earth to the moon, going 60 miles per hour, it would get there in 166 days. That would be one mighty jump for a cow. Now, you've seen the different phases of the moon as its shape changes during months' time. As we've had a supermoon out there recently, so that's pretty cool. As the moon orbits Earth, we see different amounts of sunlight reflect from the moon's surface. At the same speed, who remembers how long it would take to get from the sun from the Earth to the sun from the Earth? 177 years. Opposed to days, right? Okay, now sometimes the moon, Earth, and sun line up so that one is hidden from view. This is known as an eclipse. The solar eclipse happens when the moon comes between the sun and the Earth, hiding the sun so some people on Earth can't see it. A lunar eclipse is when Earth comes between the sun and the moon. When this happens, people on Earth see Earth's shadow on the moon, making the moon appear dark or even seem to disappear. It's just hidden for a short time in Earth's shadow. Planet Earth moves in two ways. The first we've already talked about. It travels in a circular path or orbit around the sun. The actual path of the Earth's orbit is not a perfect circle. It is just a little longer in one direction than the other. This name for this type of nearly circular path is an ellipse. An orbit that is shaped like an ellipse is described as an elliptical orbit. It takes Earth 365 and a quarter days to orbit the sun one time. So the Earth's year is 365 days. You understand every 4 years why we have a leap year? Yeah, there you go. The amount of time it takes a planet to orbit the sun one time is called its planetary year. All the planets have different planetary years, and we'll go over that. But what about the extra half day? Why don't we count it? Actually, we do count it. We just don't count it every year. Instead, we add up this extra quarter day every 4 years in a row that make one full day. Then in the fourth year, we add that extra day to the end of February. So once every 4 years, it has 29 days instead of its usual 28. We call this year with an extra day a leap year because everything leaps ahead by one day. The second way planets in our solar system move is by spinning as they orbit the sun. Have you ever spread your arms wide and twirled yourself around until you were so dizzy you could hardly stand up? Can you feel the axis or center line of your body? What part of your body rotates or spins around your axis? Maybe you've played with a spinning top or seen the ice skaters spin quickly around and around on one foot. This is what it means to rotate. But when a planet rotates, it doesn't twirl around on feet like you do. It spins on an imaginary line that goes from the North Pole to the South Pole, right through its center. The imaginary line is called the planet's axis. One day is the amount of time it takes a planet to rotate one time around on its axis. A day on Earth is 24 hours. These 24 hours are divided into daytime and nighttime. As Earth rotates, half of the Earth faces the sun and receives the sun's light, and half of it doesn't. So you have half of it's in the dark, while the other half has light on this side. Okay? Good. It is daytime on this side of the Earth, but at the same moment, the opposite of the Earth is facing away from the sun. This side of the Earth is not receiving any sunlight, so it's dark there. It is Earth's shadow. It is in Earth's shadow. It is nighttime. It's like when you stand outside on a sunny day and you face away from the sun, and you have the shadow in front of you that's keeping the front half of you in the dark, or not with the sunlight. Your body is the shadow that is cast. That's what you see. So the Earth's shadow is in nighttime. Now, we don't feel the Earth spinning. From our viewpoint, it looks like the sun is moving and the Earth is not. After all, doesn't the sun appear to rise early morning in the east and set early every evening in the west? We don't feel Earth spinning. From our viewpoint, it looks like the sun is moving and the Earth is not. After all, doesn't the sun appear to rise every morning in the east and set every evening in the west? This daily motion of the sun from east to west might make it seem like the sun is moving around the Earth, but it's not. You are moving around the sun, or really the Earth is. In the morning, the part of the Earth you are standing on is turning away from the darkness and rotating to face the sun. When the sun is at its highest point in the sky, Earth is rotated, so you are fully facing the sun. In the evening, Earth turns away from the sun, and it becomes dark again. Why is it dark? Because you are in the shadow of the Earth. It is night, and you go to bed. But as you sleep, Earth keeps rotating on its axis, and before you know it, your side of the world will have turned to face the sun again. You and part of the Earth on which you live will once again move out of Earth's shadow. And you will know that one rotation of the Earth, one day, will have ended, and another one will just be beginning. Days turn into months, months turn into seasons. What is your favorite season of the year? Fall? Winter? Spring? Summer? They all seem to happen on the same day around here. You might know what your favorite season is, but do you know what causes the seasons? It is the combination of the two motions of the Earth we've been talking about, Earth's orbit around the sun and Earth's rotation on its tilted axis. Remember, an axis is the imaginary line that goes through the center of the planet from its north pole to its south pole, and then points out into space in both directions. But a planet's axis doesn't always point straight up and down, like the axis of a spinning top. Many planets, including Earth, have an axis that is tilted a little to the side. This tilt is the key to understanding Earth's seasons. Because Earth is tilted, there is a time of the year during the Earth's orbit around the sun that is the North Pole. And therefore, the whole northern hemisphere is tilted a little bit toward the sun. This tilt gives the northern hemisphere longer periods of daylight and shorter periods of nighttime darkness. Longer periods of daylight give the sun more time to warm Earth, so it gets hotter. And the tilt of Earth's axis also makes the sun in the northern hemisphere appear higher in the sky at noon. When the sun is higher in the sky, its rays hit the Earth more directly, at less of an angle. The more directly the sun hits the northern hemisphere, the better job it does at heating that part of the Earth. So it is the tilt of the Earth which causes longer periods of daylight and a high noontime sun that makes summer happen. Well, it is the summer in the northern hemisphere. Let's see what's happening in the southern hemisphere. Why is it winter on this part of the Earth? The reason, again, is the tilt of the Earth. When the northern hemisphere is tilted toward the sun, the southern hemisphere is tilted away from the sun. This causes the southern hemisphere to have shorter periods of daylight and the sun to appear lower. Look, I'm the planet. Hello, sun. Sorry. This causes the southern hemisphere to have shorter periods of daylight and the sun to appear lower in the sky at noon. Shorter periods of daylight give the sun less time to warm Earth, so it's cooler. And when the sun is lower in the sky, its rays hit the Earth at a more direct angle, or a slant. This angle makes the sun have to heat a larger area of Earth with the same amount of energy. And this means the sun does not feel as warm. The rays of sunlight are less direct and less intense. It is colder. It is winter. I mean, imagine opening your refrigerator and leaving it there. After a while, that entire refrigerator is trying to refrigerate your entire kitchen. It doesn't, and all the energy it's going to expend, and it's probably going to break your refrigerator. So don't leave your fridge open. Anyway, in a story there. As Earth continues its orbit around the sun, the axis of the Earth always stays pointed in the same direction. So when Earth reaches the opposite side of the sun, the South Pole instead of the North Pole is now tilted toward the sun. This means that the Southern Hemisphere has summer and the Northern Hemisphere has winter. The seasons in the Northern and Southern Hemisphere are always opposite each other. This is because only one of them at a time is tilted toward the sun. So now you know the first part of your space address. Your school is on planet Earth. And planet Earth is part of your space address. So now that you have that information, you would need to answer your extraterrestrial being that might ask where your school is located in the universe. We're located on Earth. There you go. So our school's name is Patrick Henry, 3820 41st Street, Tulsa, Oklahoma, USA, planet Earth. In the next lesson, you will learn more about the next line of your space address. Oh, look, there's a map of the city again. Very nice. But we are not going to go through all of these questions right now. They are helpful and they are here for you to look at. I will have questions for you on the Canvas platform. A discussion question and an assignment will follow each lesson. The first one should already be posted onto Canvas. You can take a look at those. I'm going to just scroll through these questions real quick, though. So if you have time and would like to help yourself remember some of the things you learned in the read aloud, these are all questions based on the lesson that you just heard. What types of eclipses you have, rotation of the Earth, when the sun rises and sets. Again, you can rewatch this anytime and go back through here. And the questions that I ask you are going to be on the Canvas platform, which I'll show you, going to look similar to, well, this is where you log into Canvas. You're obviously not going to be logging in as a teacher, but I'll show you what I'm talking about. It'll be in science. Actually, let's go to student view real quick. And you'll see on here the to-do list will show you different things you have coming up, activities, discussions, quizzes. You go to discussions, and yours will be posted on here once it's there. Right now you have pinned discussions to read and respond. It'll be on here once I post it. Should already be there, and you look at it after this video, and you'll be able to post responses to the discussion as well as post responses to your classmates. Expect you to post at least responses to 2 or 3 different classmates. Obviously, you'll have to wait until a lot of people post responses to do that, which is why this is going to be a week-long discussion and assignment form. It's not like it's due tonight. We're going to give you plenty of time. Flexibility is key. So the main thing is that we spend time learning this together. So thank you, students, for joining me in this lesson, and I will see you in the next one.